Chapter 1. Why Solar? Electricity made from the sun is one of the fastest growing sources of power in the United States and the world. Solar power is an important part of our electricity mix, especially as transportation, heating, and other day-to-day needs become more electrified. Solar power can help us cost-effectively diversify our energy resources while addressing environmental concerns like pollution and climate change. Solar projects provide opportunities for local landowners and communities to diversify their income while providing jobs, tax revenue, and economic opportunity. At the same time, solar projects are quiet and have minimal visual impact on the landscape. Chapter 2. About solar. The photovoltaic effect can directly convert energy from the sun into electricity. Photovoltaic (PV) technology uses semiconductors within the solar cells to release electrons from their atoms when exposed to light. The flow of electrons in a circuit from the positively and negatively charged semiconductor layers creates an electric current. Multiple PV cells are connected to form a solar module, and each module is linked to create a solar array. The panels convert the sun's light into direct current electricity. Expanding the number of modules increases the electrical output. Solar systems are scalable and can be used in a variety of configurations. Solar panels are widely used on homes, schools, and carports. Chapter 3. Touring a solar project. Large solar projects are often referred to as large-scale or utility-scale solar projects because they function like a traditional power plant, generating a large amount of electricity that is collected and delivered to the utility at a designated interconnection point. When passing a solar project, you will see rows and rows of solar arrays mounted in clusters or blocks to absorb the maximum amount of sunlight per day. Interspersed among the arrays are inverters, which convert direct current into alternating current. The alternating current electricity then travels via cables to a transformer, where the electricity's voltage is increased before being injected onto the electric grid. A solar project often includes a convenient operations and maintenance building that houses local power plant controls and office, meeting, and break room areas for on-site staff and visitors, as well as storage space for spare parts and other equipment inventories. Apart from some access roads, the land is almost completely covered with locally appropriate vegetation that is designed to manage dust and control erosion while not interfering with the solar panel's operation. Native and pollinator-friendly plantings can be used to enhance soil quality and preserve agricultural land for future use. The entire area is surrounded by security fencing. Chapter 4. Building a solar project. When deciding where to build a solar project, we consider 3 main things. 1. Location. 2. Permitting. And 3. Economics. Location. The most crucial aspect to consider when evaluating a location is the amount of direct sun exposure to the PV panels, the availability of land, and the proximity to transmission infrastructure to get the electricity where it needs to go. We test the soil and assess weather conditions to determine potential risks and to forecast maintenance and operational costs for the project's useful life. This research allows us to estimate power output and meet customer needs. Permitting. Local and state permitting rules determine whether the project can meet the land, environmental, tax, and other requirements important to the local jurisdiction. The permitting process includes meeting with local stakeholders and getting community input. Economics. In the end, a solar project can only be built if it is economically viable. The economics of a project depend on its ability to maintain a stable revenue base. This typically includes a power agreement with a long-term customer. It can take 2 to 3 years to put the pieces in place to move from early development to the construction of a solar project. Once started, construction of a large-scale solar project takes about 12 to 18 months, creating hundreds of jobs at the peak of construction and opportunities for area contractors and suppliers to provide services. Landowners who lease land for a solar project benefit from lease payments over the expected 35-year life of the facility, while communities benefit from a new stream of property tax revenue that can support schools, first responders, and other local needs. Once the solar project has reached the end of its useful life, we guarantee through a decommissioning bond that the project area is restored to its original condition. The land can then be returned to agricultural or other uses as decided by the landowner. A solar project is a long-term collaboration, as the owner and operator We appreciate that our interests must be aligned with landowners, government officials, economic developers, lenders, and investors, among others. A solar project is an investment in stronger communities and the environment. Arevon is a leading renewable energy company, supplying clean, reliable energy to homes and businesses, and powering the energy transition across the United States. Arevon's mission-driven employees use innovative approaches and leading-edge technology to develop, build, finance, own, and operate renewable energy projects. We are excited to bring solar power and its many benefits to a community near you.